Hi class, welcome to our lesson in General Chemistry 2. This is lesson 8 and we'll be talking about spontaneous change. Again, this is Sir Alex Pasco and let's begin by first discussing what will be the goal of today's lesson. So at the end of the day, basically what I want you guys to understand is basically what is a spontaneous reaction and how you can predict spontaneous reactions using entropy, which will be actually our next lesson after this. Um, okay, so let's discuss first what is a spontaneous and what is non-spontaneous processes. So when we talk about the spontaneous processes or spontaneous reactions, are basically reactions that proceed on their own, even when you left them alone. And of course, they proceed especially in the absence of any attempt to drive them in the opposite direction. What we can also call them as natural processes. So, what do we mean by that? Example, if you have a hot cup of coffee or chocolate in this case, eventually that cup of coffee, that hot cup of chocolate will eventually become lukewarm and cold. So hindi na siya mainit. And the reason for that is because it just naturally happens. It naturally proceeds that the kinetic energy of those molecules in your hot coffee or in your hot chocolate eventually get slower, resulting in a colder chocolate or colder coffee. So that is an example of a spontaneous process. It naturally happens. So any reverse of these natural processes or natural reactions is what we call non-spontaneous processes. And going back to our example earlier, if you have a cold chocolate, for example, or if you have this cold cup of chocolate, now it can never become hot by itself. You need heat in order for it to absorb that heat, in order to increase the kinetic energy, speeding up their movement and increasing the temperature of that hot cup of chocolate or hot cup of coffee. Another example of spontaneous reactions are combustion processes that we'll actually show earlier. So, for example, if you take paper and fire, you're basically igniting the paper, combusting that paper, making the carbons on your paper react with the oxygen surrounding, and making your paper the fuel for the reaction for combustion. If you leave that fire will gonna keep going and continue until the fuel, in this case your fuel is the paper, is consumed. That is an example of a spontaneous reaction. An example of non-spontaneous reaction is you cannot reverse that. You cannot reverse the process of that burning. No, that's quite sometimes I think it's even can be difficult or even almost impossible to reverse the process of that burning. So one thing that I want you guys to think about is sometimes when we think of spontaneous, we think immediately, we think fast. But when we talk about spontaneous processes or spontaneous reaction, we are not talking about the rate of the process. We are not talking kung gaano siya kabilis. We are only talking about whether it will continue to go on or whether it will not. Again, spontaneity only tells whether a reaction will occur or not whether it will react fast or whether it will react slow, no? Because some spontaneous reaction are actually quite fast and some spontaneous reaction are actually quite very slow, even to the point that they can even take millions of years for the spontaneous reaction to happen. Example of that is diamonds. We know that graphite can become diamonds under very certain after consuming a lot of energy and a lot of pressure. Graphite can become diamonds, but it will take again a lot of energy and a very long time. That is an example of a spontaneous reaction, but it will take a long time. Again, because we talk about spontaneity, we are not talking about kung gaano siya kabilis. We're only talking about whether the reaction will occur. And we know that over time, when heated, when we exert enough heat or enough energy in that graphite and enough pressure, it will become diamond. Another example is when we are combusting alcohol. So if you have an alcohol and you light it on fire, the fire will spread pretty quickly. But a rusting iron occurs really slowly. Both are spontaneous reaction, but they happen at a very different rate. Now let's talk about the Thomson-Berthelot principle. When we talk about this is actually proposed independently by two chemists. One is a Danish chemist, Julius Thomson, and the other is a French chemist, Pierre-Eugen Marcelin Berthelot. So what they discovered is that almost or all exothermic reaction or exothermic processes are actually a spontaneous process or natural processes. Example of an exothermic, or if you guys remember the uh, meaning for exothermic, or basically what are exothermic chemical reaction? Exo meaning outside, thermal meaning heat. When we are undergoing exothermic chemical reaction, there is a release of heat. So any chemical reactions that results in a release of heat results in is an example of a spontaneous reaction. Like I mentioned earlier, combustion processes. So when we burn things are examples of exothermic chemical reactions, and they are examples of a spontaneous reaction. And we can actually see that on this chemical on their chemical equation. So the top chemical equation here, I want you guys to look here. This is a very common chemical equation for something that is burning. This is called like an oxidation. Oxidation because we are combining whatever your fuel is. In this case, our fuel is a methane. CH4 is methane, but this could be wood, a piece of dry wood, a piece of paper. When you ignite that, that piece of paper becomes the fuel. In this case, our fuel is a CH4, which is a methane. It combines with oxygen, so it oxidizes. So this is an oxidation process, and this is actually what happens when you burn things. Things oxidizes, it combines with oxygen, and it's a very quick process. And as you burn things, there is a negative change in enthalpy. If you guys remember enthalpy from, I think it was lesson 5 or lesson 4, it was along the change in phase diagram. We talk about a little bit about it, where we measure a change in enthalpy. A negative change in enthalpy, negative meaning there is a release of heat. So in this case, when you burn a one molecule of methane and combine it, or you oxidizes one molecule of methane and oxidizes it with two oxygen, you ended up with having a vapor, and you can actually see the vapor, yun yung usok na lumalabas kapag nagsusunog kayo ng bagay, and you basically have carbon dioxide as well, and then you also have soot and etc. etc. But as you burn things, papansin nyo as there is an increase in temperature in the surrounding. That is a release of heat, no? That's why we have a negative enthalpy. Delta H is a uh, change in enthalpy. And since this is negative, meaning there is a release of heat. So all of these examples right here are all examples of combustion. We're oxidizing them. We are combining oxygen with basically our fuel. Now in this case, we have two atoms of dihydrogen, and in this case, we have two molecules or two atoms of manganese, solid manganese. And if you combine them, you oxidizes them, there is a negative change of enthalpy because there is a release of heat. And what happens is that when you release heat, this is a type of a spontaneous reaction, so they happen naturally. The products are in favor. Or what when I say the products are in favor is that this process is favors the production of the products, or it favors the creation of the products. So remember that all exothermic reactions or reactions that releases energy, meaning there is a negative change in enthalpy, are all spontaneous reaction. So when you're burning wood, you can change this as your wood, whatever the chemical equation for wood is. I'm pretty sure there are carbons in there because it's an organic molecule. Now you have wood solid and you oxidizes it, you will still create carbon dioxide and water vapor, and there is a type of release of heat. It may not be 8.890, but there is a release of heat there. But of course, I want you guys to remember that not do not all the reactions follow this generalization, because uh, there are some reactions where there is no release of heat that is a spontaneous reaction, no? But just remember, all exothermic reactions are spontaneous, but not all non-exothermic reactions are non-spontaneous. So as an example, melting ice. So when you leave ice in, for example, on your glass, no? Kapag bumili kayo, halimbawa, punta kayo sa McDonald's and you ordered a glass or a cup of whatever soft drinks you want to buy, soda, for example, Coke, and that Coke has ice on it. After drinking, you see that the ice starts to melt, no? And the reason for that is the ice is actually absorbing heat. So, ang nangyayari, instead of releasing heat, it is absorbing heat. There is a positive change in enthalpy, but it is still a type of a spontaneous reaction because ice will eventually melt. No? Saan ka ba nakakita ng ice that or water that solidifies itself when you leave them in room temperature? So melting ice is a type of a spontaneous reaction, albeit it is not a exothermic reaction. It's actually an endothermic reaction. But just again, I want to make sure that you understand that all exothermic reactions are spontaneous, but not all non-exothermic are non-spontaneous. Non-spontaneous. Some non-exothermic reactions are still spontaneous reactions. And so the question now is, if some chemical equations or some chemical reactions are non-exothermic, if the how can we know if the equation is spontaneous? So now, for example, so positive yung enthalpy ko. Pero paano ko malalaman kung yung equation is spontaneous? No, kung hindi siya exothermic. So another, like a condition that spontaneous reactions have to meet is the second law of thermodynamics. So we're going to talk more about this when we talk about entropy, because it talks more about entropy, which is very related to spontaneous reaction. And again, this will be our second lesson or next lesson after this. So second law of thermodynamics states that as energy is transferred or transformed, more and more of it is wasted. There is a natural tendency for any isolate system to degenerate into more disordered state. What do we mean by that? I want you guys to remember, think of disordered state as it is, yeah, chaos, but think of it as the molecules not being able to work, or for the molecules or for the reaction not to be able to produce any more work. So as energy is transferred or transformed, so for example, burning of the wood. So yung kanina, yung moving picture kanina, you have a burning wood here. That burning wood, there is a transfer of energy from the wood, from the fuel and the oxygen to the outside environment, and that energy is in form of heat, no? And that heat warms you. You can use that heat, especially during winter. We don't have winter, pero if you experience a very cold For example, very cold night in Baguio, you can do a campfire, and the heat from the flames of the campfire is a form of energy that is transferred to you. And the more you took energy from that heat, the more of it is wasted, because you can think of them as basically spreading all around you and spreading into the universe. And nangyayari, the more you transfer nangyayari, the more burning na nangyayari, the more transfer of energy na nangyayari from the system, which is the campfire, to the surrounding system, which is you and your environment, the more of it is wasted. Kasi in our universe, there's actually a natural tendency for any isolated system to degenerate into more disordered state. So from the molecules being in an ordered state, being wood and being oxygen, to a more disordered state wherein they're just bunch of heat energy na lumabas, and it warms you, and now after warming you, it is now wherever in the universe, because any spontaneous processes increase the disorder of the universe. When we talk about this disorder of the universe, we are mostly talking about entropy. Entropy is basically when reactions cannot do work anymore. Another explanation is, for example, you want to clean your room, and in order for you to clean your room, you need energy. So you ate something. Let's say kumain ka ng lunch mo, and your lunch was a burger, no? And that burger, after eating it, after consuming it in your body breaks it down, no? So you can think of the burger as a very ordered siya, no? It has a order because, uh, yeah, you can think of the burger as orderly. So it has a structure. Hindi siya disordered, no? But when you consume it, your body starts to break it down. So it starts to become smaller parts and smaller parts. It becomes carbohydrates, it becomes lipids, it becomes cholesterol, it becomes fats, no? It becomes other things that your body needed. So, and then those lipids, carbohydrates, they even your body starts to break them down even more so that your cells can use them in order to create ATPs. And then when your body breaks them down into more um, smaller particles for cell processes to create ATPs, which are the energy needed for you in order to work, to move your muscles, etc., etc. Ang nangyayari that burger becomes more disorder, kasi it starts to break down, and then your body does not only use it for you to be able to clean the room. Your body will start using that burger consumed, that orderly burger, and it starts to disorderly put them in various parts of your body. The energy, it will use it to um, for your heart to keep pumping, for your for your eyes to keep seeing, for for your brain to keep processing materials. So kumbaga, that orderly burger na kinain mo, that you want to use, or that you want to use to can I explain this for you, that you may want to use to clean your room. Ang gagawin ng katawan mo, hindi na naman niya gagamitin yung burger na yun as an energy for you to clean your room. It will use that to use the energy for your other functioning ng katawan mo. So it is basically everywhere in your body. There is a disorder now. So kumbaga parang ganun yung idea. I hope it's understandable. That's kind of like how I can explain it na medyo mas easy na maintindihan. But basically, disorder in a sense na after it was transferred over your body and it is used, it cannot do work anymore after it's used because it's already there. The same thing. So it follows the second law of thermodynamics that when the energy is transferred, the more of it is actually wasted. And then the tendency is that the universe usually directs more into a uh, disordered state. So I hope that's clear. If it's not clear, you guys can message me and we can talk about it one on one so I can explain it more. Pero in summary, basically this is what it is, no? So you have two processes. So you have two processes. So you have spontaneous process and you have non-spontaneous process. The spontaneous process usually have a negative enthalpy because again there is a release of energy usually most of the time most of all exothermic reactions are negative enthalpy, but there is a positive entropy because it's leading more into a disordered state. We usually denote that as positive S. So when a reaction has a negative enthalpy, there is a release of heat and there is a positive direction towards disordered state, or there is um, a tendency for it to be in a disordered state or positive entropy. It is a spontaneous reaction, and what happens to this is it favors your products. So what we mean when it favors products is the chemical reactions has a tendency to keep producing the products as long as you have the reactants. Well, for non-spontaneous, for most of the time they have positive change in enthalpy. The reason for that is because it wants to absorb heat rather than release heat, and it has a negative entropy. The reason for that is because it wants to keep its order, and it usually favors the reactants. And when it favors the reactants, the reaction process does not happen spontaneously. Hindi yung reactant mo does not usually become the product. Okay? So without you forcing these reactants to react, hindi sila mag-react. So kahit kaano pa, for example, you keep burning it, hindi matutuloy yung apoy because it's non-spontaneous. Kumbaga, if the chemicals are non-spontaneous. Okay, so I hope that is clear. And lastly is for spontaneous reaction, there is a what we call a equilibrium constant that we're going to talk about, the entropy, which is our next lesson. For spontaneous reaction, usually entropy is usually greater than 1. Is it greater? Yeah, oh yeah. So it's usually uh, k is greater than 1. It's usually, so this is an equilibrium constant. So just remember this for now. We're going to discuss this when we start talking about entropy in our next lesson. So when your equilibrium constant is greater than 1, it is a spontaneous reaction. But if your equilibrium constant is less than 1, so meaning it's 0. Blah blah blah, 0 0.5, 0 0.3, it is usually a non-spontaneous reaction. So just remember this for now. We will use that in our next lesson. So that is basically what the spontaneous and non-spontaneous reactions are. I hope it's clear. If it's not, you can contact me and we can talk about it so I can explain more. But that's our lesson for today. And thank you so much. I hope you guys have a great day.